Hey guys, welcome to the Raptors, a digital platform of the REPT Excellent Tutorials. So, as a part of the revision plan, you know that CBSE have released the tentative date sheet for the examination, CBSE examination. So, it is high time, guys, that you start preparing for the start preparing with revision and for the board exams, guys. So as part of the series that we told you that we are going to help you with the comprehensive revision plan. So today we are going to start with electrostatics. We will be doing starting with physics, class 12th physics, and the first chapter. We'll be revising first chapter electrostatics, guys. So electrostatics. What is electrostatics? It means charges at rest. Now, it talks about charges, guys. Now, so to understand what are charge, let us try to understand the basic nature of charge. You know, everything is made up of atom, and atoms are made up of proton, neutrons, and electrons revolving around it. So electrons are negatively charged, protons are positively charged. So properties of the charges. Like charges repel, and unlike charges attract each other. The second property is charges are additive in nature. That means if you have Q1 is equal to 2 coulomb, Q2 is equal to 5 coulombs, and you can add Q is equal to Q1 plus Q2, and you have 2 plus 5 coulomb, that is 7 coulomb. Now the third property, guys, are charges are conserved. That means total initial charge equal to total final charge. That is Q initial is equal to Q final. That, for example, if you take the ionization of sodium, gives you sodium plus and plus one electron. So total initial charge is 0, and total final charge, if you calculate it minus 1 plus 1, the total charge is Q final is 0 and Q initial is also 0. So this shows quantization of charge, guys. The fourth property, which is very extremely important property, is quantization. What does quantization mean? It means that Q is equal to plus minus Ne. What does that mean? It says that smallest possible charge that exists freely in nature is equal to the charge on an electron. What is N? Here Q is charge, N is number of electron charge, and E is charge on an electron, which is 1.6 into 10 to the power minus 19 coulomb. So these are the four properties which charges follow. Now we go quickly to Coulomb's law. What is Coulomb's law? If you have 2 point charges Q1 and Q2 separated by a fixed distance AB, which is R, so Coulomb said force is directly proportional to Q1 and Q2 and inversely proportional to R square. So force is proportional to Q1 Q2 by R square. So force will be K Q1 Q2 by R square, where K is constant. K is 1 by 4 pi epsilon naught, whose value is 9 into 10 to the power 9 Newton meter square per coulomb square. So you see the very high value of constant K shows that electrostatic force is very strong. You know, it is really very strong as compared to gravitational force, guys. So using this formula, one can find out the force between two charged particles. If you want to write Coulomb's law in vector form, one gets force is equal to K q1 q2 by r square r cap, where r cap is r vector divided by its magnitude. So it will be k q1 q2 by r square, r vector by its magnitude. So it becomes k q1 q2 by r cube r. So the vector form is this. These two forms are in the vector form. So this is Coulomb's law in vector form. So suppose there are two forces, F1 and F2, separated by angle theta. The resultant F, magnitude of this force F, will be given by F1 square plus F2 square plus 2 F1 F2 cos theta. The angle the resultant will make with one of the forces is tan beta is equal to, let this angle be beta. So tan beta will be F1 sine theta divided by F2 plus F1 cos theta. So we can use this formula to solve different problems. Like situation can be like this. See, suppose there is an equilateral triangle and each has side A, and charges, different charges are there. Suppose you have Q1, Q2 minus Q3. So if you want to find total force at A, the force exerted by Q2 and Q1 will be along this direction, F1, and due to Q3, because this is negative, it will attract F1, so the force will be F2 in this direction. Resultant force will be F along this direction. Since it is equilateral, this angle will be 120 degrees, so we can use this formula to find value of F. We can also find the angle it will make with F2 using this formula, guys. So we are running, guys, we are running the revision series for board exam of physics. So we have begun with electrostatics. So the next thing is electric field. So we go to electric field. Mathematically, electric field is very similar to electric force. So if you understand electric force well, electric field is very easy and straightforward for you guys. So what is electric field? How it is defined? It is the force, you may say electric force per unit charge. So E, magnitude of E is given by force per unit charge. So expression will be 1 by 4 pi epsilon naught q by r square. So you see, because you are dividing one of the charge, so one charge force is k q1 q2 by r square, so one charge gets cancelled and you are left with one charge. In the same way, just like you wrote electric force in vector form, electric field can also be written in vector form. So we can write in vector form as E equal to K Q R square R cap, and you know R cap is R vector divided by magnitude of R, so it becomes K Q R cube R. Now, just like electric force, the resultant of the electric field can also be written like this. Suppose you have E1, E2 separated by angle theta, the resultant E will be E1 square plus E2 square plus 2 E1 E2 cos theta. And this angle beta can similarly be calculated as E1 sin theta divided by E2 plus E1 cos theta. What kind of problems you get from electric field? So there are types of problems that are generally asked in electric field is: number one, you have 2 point charges q1 and q2 separated by a distance, a fixed distance a. You want to find a third point C where the net electric field is zero. So you see, if the net electric field is zero, the electric field due to Q1 and Q2 must be equal and opposite. So let point C be at a distance x. So CB will be A minus x. Now, according to question, magnitude of F1 should equal to magnitude of F2, or E1, magnitude of E1 should be equal to magnitude of E2. So you'll have K Q1 by x square should equal to K Q2 by A minus x whole square. K gets cancelled and you get A minus x whole square Q1 and Q2 x square. You solve this quadratic equation and you get the value of x. That's how you solve such problems. The other type of problem, guys, that you generally get is, suppose there is an oil drop and oil drop of mass m and charge q. What should be the value of electric field just so that this oil drop keeps hanging in air? So for this oil drop to keep hanging in air, the gravitational force, which is mg, must be balanced by the electrostatic force. So electrostatic force must equal to gravitational force. So k q by r square must equal to mg, k q1 q2 by r square. Or since it will have some electric field, you may convert it as q, this charge q into E is equal to mg. So from here, E can be calculated as mg by q. So you can find the electric field that is required to keep the oil drop suspended in air. Now the third kind of problem you get is similar to what we discussed in electric force. There is an equilateral triangle and you have charge q1 here minus q2 here. You need to find total electric field at A. So this is A, it is an equilateral triangle. The electric field due to this will be along this direction, and due to Q it will be along this direction. So we can use this formula. Two electric fields are there and the angle between them is theta. Here, since it is an equilateral triangle, ये angle कितना होगा? It will be 60 degrees and this angle will be 120 degrees. So the net electric field will be E and its magnitude will be given by this formula. These are three kinds of problems which you generally encounter in electrostatics, in electric field, guys. So we are, guys, just to remind you, we are running quick, brief and crisp revisional classes so that you can cover your leftover things. You can revise your things quickly, crisply, and well. We'll provide you notes as well for your further reference.